Okay, so we are looking at a few simple concepts on the idea of vectors. So to start off here, a vector is a quantity that has both magnitude, which is length, and direction. So it has to have a length and a direction. So for a vector in a plane, it's convenient to use an arrow to represent the vector. So notice it's like a ray. It's not going to be a line where we usually have arrows on both ends. The length of the arrow represents the magnitude, while the arrowhead indicates the direction of the vector. So compass direction is measured in degrees clockwise from due north. All right, so if we're looking at this one here, its magnitude is its length, which that, of course, would be 5. And its compass direction, remember, it's degrees from due north. So we're talking from straight north over here. So that would have to be this 90 degrees here plus the 20 degrees, which would be 110 degrees. It's direction from due north. So we can have two vectors that are equal if they have the same magnitude. Remember, magnitude is its length and the same direction. So their position does not matter. So these two vectors here are equal because they have the same magnitude and the same direction. And here we're talking about the points, the parts of this vector. So this is the name of the vector. This would be vector u. Its initial point, or like where you start, that's its tail. And its terminal point, so where the arrow is, that's its tip. So we can do these operations with vectors, and we call this method tip to tail. So simply place the tail of each successive vector to the tip of the previous vector. So the resultant vector is drawn from the first tail to the last tip. All right, so over here, we have these two vectors up here at the top. So I have vector u and vector v. Well, the first thing we need to do is to figure out like their component parts. So that's kind of like the slope here, but we always want to move left or right first. We want to start at the the tail and go to the tip. So if I'm looking here at u, I'm going to move that to the right and this down, right? So I'm going to move 4 to the right. And since I'm moving to the right, that's a positive 4. And now I'm moving down to get from this to this point, right? So I'm moving 1, 2, 3, 4, 5, 6, 7, 8. So I moved right 4, but I moved down 8. So for vector v here, going from tail to tip, I'm going to go left or right first. I want to do my x first. It's kind of the opposite of how we do slope, right? We usually, when we're thinking of slope, we move up or down first. So here I moved 1, 2, 3, 4, 5, 6 to the right. So that's a 6, and I moved 2 up. So if we were going to write this with its component parts, u, and this is how we show that it's a vector. We put this little like, not a parenthesis, it's like a V, a sideways V there, right? So our x went right 4, and we went down 8. So I don't have to list both of these points here for my vector. I'm just listing their component parts because I could start this vector anywhere as long as wherever I start, so my tail, if I went 4 to the right and down 8, I have the same vector. So for vector v, if I'm going to list it with its component parts here, I went right 6 and up 2. And again, I could start anywhere. It doesn't matter where I start. Okay. So if I'm looking at number 1 here and I want to do the scalar multiplication, so I want to do 2u, that just means I need to do u twice. So again, I can start anywhere. So let's say I started here, and I know I got to do this twice. So I need to kind of start up to the left a little bit. So I want to do u twice. So I'm going to do 4, 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5, 6, 7, 8 down. So there's u. But I need to do 2u, so I would have to do this again. So this is u, and then I would do it again. 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8. So there's my second u. Now this U, this whole thing here is called, sorry, it's off the screen a little bit. The whole thing is called the resultant. And when we do the resultant, we want it to be either in a different color or we can highlight it. I didn't bring any highlighters in here with me. So I'm going to just do it in a different color. I'm going to dash it here. So my dash line is my resultant vector, so that would be 2u. Okay. Let me pause this for a second. I'm going to get a highlighter. Okay, I am back now. So let me switch over here so I can make sure I'm on the screen. Okay, I did it in gray there. It's hard to see, so let me just do it in pink here. So my resultant is the whole thing. And that's my resultant there. Okay. So now what if I wanted to do something like u plus v? So I'm going to graph u first. Whatever one comes first, we're going to do that one first. So u is, again, remember, start wherever you want. So I'm going to start u here. So u, remember, this is its component form. So I'm going to move 4 to the right and down 8. So 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8 down. All right, so there is u. Now when we add these together, this of course is my u. My v is going to start where u ended. So at this tip, I'm going to start the tail of v there. And v, remember, this is our component for v. We go 6 to the right and 2 up. So from the tip on this one, I'm going to go 6 to the right, 1, 2, 3, 4, 5, 6, and 2 up. So this is v. So vector addition, my answer is not this. My answer is from the tail where I started in the very beginning to the tip where I ended after we finished. So this is my answer. This is my resultant vector. This one is u plus v. So we are talking about, sorry, this piece here. Now remember, it does not matter where you start. You can start anywhere. Okay, so addition, there we go. All right, now if we're talking about subtraction though, that means that we're just gonna go the opposite direction. So, but whatever one's first, do what it says. So I'm gonna do u first, and remember u is 4 to the right and down 8. So that's what we did at the top. So I'm gonna pick a point. I'm gonna go 4 to the right, sorry. 1, 2, oh, I'm in the wrong color. U is in blue, hello. All right, so 4 to the right, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's my u. Now, remember, v usually goes 6 to the right and 2 up. So when I'm subtracting, I'm going to go the opposite direction. So v again usually goes 6 to the right and 2 up. So the opposite of that, because this is a negative, right, or a minus, instead of going 6 to the right, I'm going to go 6 to the left. So 1, 2, 3, 4, 5, 6. And v usually goes up 2, so I'm going to go 1, 2 down. And my arrow is going to change directions, right? Usually v goes up and right. Now it's going to go left and down. All right, my resultant, this right here is a minus v. My resultant is from the tail where I originated it in the very beginning to the tip where I ended. So we are talking about this right here. So this one is u minus v. So this is my resultant. is that going to be the same if we do this one over here? So instead of doing u minus v, if we did v minus u, are we going to get the same answer? Well, let's check it out and see what happens. All right, so now this one says to do v first and then subtract u. So v, I'm just going to start v wherever I want. How about here? So v says 6 to the right, 1, 2, 3, 4, 5, 6 to the right, 1, 2 up. All right, there's v. Make sure you got your arrow. Minus u. So u says 4 to the right and down 8. So because we are doing minus u, we're going to do the opposite, right? So instead of going 4 to the right, we're going to go 4 to the left. 1, 2, 3, 4. Instead of going down 8, we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So this. So my resultant, where I started in the very beginning to where I ended, my tail to my tip, whoops, did this all, but that's okay. This is v minus u. Is it the same? It is not the same because I'm going in the opposite direction. It looks similar, but I am going in the opposite direction. Remember, to be the same, they have to be the same magnitude, which these are the same magnitude, but they have to have the same direction. And these are not going in the same direction. V minus u is going up. U minus v is going down. So that's the difference. All right, was I even on the screen the whole time? Who knows? All right, so this one's going down. This one was going up. So those are not the same. Okay, and you could combine and do this. We're not going to do these. You could do u plus 2v. So I would draw u, and then I would draw v twice. This one, 2u minus 1/2 v. So I would draw u twice. And then I would only go half the distance on v. All right, let's look at this one thing down here at the bottom, and that's called its magnitude. And we know from the page before that the magnitude is the length of our vector. So when it's written like this, this is what we have here. So you should see, or you should kind of think about, well, this is a right triangle, or we could make a right triangle out of this, right? And I could find the length of this piece by doing the Pythagorean theorem, and that's where this comes from, because if this is our y and this is our x, then this would be like z, right? We would have x squared plus y squared equals z squared. So this is just solving for z, so we would take the square root of both sides. So u, or the magnitude of u, is the square root of their sides squared. Now what are our sides here? So our x length here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got 11 squared plus 1, 2, 3, 4, 5, 6, 7, 8. So that's the square root of 121 plus 64, which is the square root of 185, which is if we're talking about a length, saying the square root of 185 doesn't really help us, right? We need to know the length. So in this case, we would want it to be, I don't know why I wrote the square root again. This is going to be a decimal. So the square root of 185 is 13 when we go to 3 decimal places, right? So 13.601. All right, so that's a little bit about vectors geometrically. So now we're going to look at vectors algebraically. Let me stop this video and then we'll start a new one for the next one. I gotta find where to stop, sorry.